So morning today we'll discuss about the chapter network layer protocols and IP addressing. Okay. So here we'll discuss about network layer protocol, then IPv4, IPv6, ICMP, different protocols coming on the network layer. Okay. And how do we assign IP address? How do we perform subnetting? All the basic things. Okay. So start with network layer protocols. So here we have the purpose of network layer is IP address assignment and routing. Okay, so for that purpose we have ICMP protocol, means Internet Control Message Protocol, then IPX Internet Packet Exchange Protocol, then IP Internet Protocol. Okay, so the purpose of network layer is IP addressing and routing the data or packets. It contains three protocols. Now, in detail about IP. IP stands for Internet Protocol. Okay, it is a protocol which provides logical addresses for devices at network layer. That means this is a protocol which gives you logical or IP address. So it is responsible for addressing and forwarding data packets. So it's a protocol which provides IP address in the network is called as IP or Internet Protocol. And there are two versions, IPv4 and V6. You know, IPv4 is the 32-bit address, like we have dotted decimal, like example 192.168.10.10. IPv6 is 128-bit. We have more addresses in that IPv6. It will be in hexadecimal number, and they are having colon as a separator. 2001 colon DB8 colon AZAD, like that. Okay, mentioned over here. Data encapsulation. So every OSI layer model layer now has encapsulation process. So we call that PDU, protocol data unit. Every layer makes a PDU. So here, application layer PDU is called as data. The actual data, they didn't do anything, just the PDU is the data. Transport layer, they will add a header, transport layer header, along with the data, and we call it as segment. What they will add in the transport header is port number, source port number, destination port number. In the network layer, we will add network layer header on top of the data which we get from the previous area. On top of segment, we will add the network layer header, and that header is called as source IP address and destination IP address. Okay, so when you add that source IP address and destination IP address, the network layer PDU will be called as packets. Okay, when we go to data link layer, along on top of this packet, what they will do, they will add data link layer header and tail. So we call it as frame, and what they will add there, source and destination MAC address and error correction. Okay, data. Then physical layer, we will convert data into that particular whatever data frame we have, will convert it into bits. Okay, this is what happening. So in network layer, the main thing, the data encapsulation. What we encapsulate is we add network header. What is inside network header? It has source IP address of the machine which is sending, and IP address of destination machine which we are going to communicate. Okay, then the whole thing is called as packet. So somebody asks you what is a PDU or protocol data unit of network layer, called as it is packet. Okay, it's mentioned over here. So the packet IP for packet header, it contains this much field. Okay, so important thing is source IP address of source computer, then destination IP address of destination computer, version. Here you should mention whether we are using IP version 4 or Internet Protocol version 6. Length of the header, type of service. Here depends upon the quality of service. Okay, high priority, you have to mention the type of service. So see here, 8 bits long. What type of service you are using? Okay, so differential service is for differentiated service for quality of service, no high priority service. Okay. Then total length of the data 16 bits. Identification. So here no, we have a concept called as fragment. So the packets will be of big size, but the network has a lower maximum transfer unit. Okay, how much data, how much bytes you can transfer in the network? No, that is maximum transfer unit at a time. Okay, so if that MTU is lesser than the packet size, what we should do, we have divide the packet into small segments. So we call it as fragments. Okay, so identify the fragments, we need identification. So that's what identifying 16 bits long. It is for fragment reassembly. Whenever we divide the packet into fragments, no, to reassemble them, we need identification number. Then we have flags for 3 bits long for identifying what type of how we do the fragmentation. Okay. Then fragmentation offset means 13-bit long. This also used for identifying, okay, from where to where, which fragment, first fragment, like, okay, then from 0 to say 187 first fragment, then from 187 to say 300 another fragment. That's what offset. Okay, it shows you that how long is the fragment. Okay, time to leave. Every packet has a time to leave. So this is to avoid looping. Okay, so if a packet loops in the network, it is not reaching the destination, means the network capacity bandwidth is being wasted. So what we'll do, every packet flowing in the network will have a time to leave factor. Whenever the packet reaches the router, that router, whatever router is receiving the packet, no, they will reduce the TTL by 1. Whenever the TTL value of packet reaches 0, that packet will be dropped from the network. This is how we avoid the looping in network. Okay, or layer 3. Protocol. What is the protocol used? Okay, what the packet is being going through. The protocol means the packet will be processed by many protocols. Okay, so what type of protocols are there? So here we have ICMP protocol will be processing the packet. IGMB will process the packet. Then TCP, UDP, all these protocols will be processing the packet. Okay. Then checksum. There is checksum. This is used for error correction. Okay, this is for error correction. So whenever you get a packet, you have to make sure that the packet is free of errors. Nobody has done any manipulation or correction of the packet. To avoid that, we can have checksum. So like mathematical calculation to check whether the error is there or not. Okay, this is what coming under the IPv4 packet header. Then packet fragmentation. See, as I told you, we want to divide the packet into smaller fragments. See here, the data is a bigger one. We say example a movie file. Okay, so the host A want to send a big data to host B. What the router, no, what they will do in the network, no, they will divide this into small pieces, and they will send it as a small piece or a fragment. Why? Because the size of packet is more than the maximum size supported by the data link. Okay, the maximum transmission unit is lesser than the packet size. So what we will do, divide the packet into small fragments or pieces before transmitting to the link. Okay, so we discussed about the flag. No, here we have flag. Okay, what are that flags? Okay, so flag reserved 0. Okay, this was reserved fragment means 0, starting with 0. Then down fragment means if the value is 1, means indicates that we cannot fragment that particular packet, cannot divide that into small pieces. Okay, that is the smallest piece. Then more fragment means this value is 1, means indicates that there are more segments or fragments followed by this fragment. Okay, 0 means there is a last fragment, last segment. Okay, this is the extra thing. Remaining all we discuss in the IP address header part. Okay. As I told you, time to leave. Whenever the host sends a packet towards another host, whatever routers or gateway routers on in between these machines, no, they will take the packet and they will reduce the TTL by 1. So, example, when I send a packet from host A, first it reaches R, this first router. What they will do, the TTL value is 255, they will reduce by 1, 254. Now, this one will reduce by 1, 253. Like that, whenever this reaches 0, the packet will be dropped from the network. This is used to avoid the looping in the network. Okay, mentioned over here. Then protocol indicates what are the protocols which process the packet. Okay, which I told you. No, it will be like TCP. UDP means TCP means see this port number 6. The which one? Sorry, protocol number is 6, and the UDP means protocol number 17. Okay, the number of the TCP is 17. Okay, the application port. Okay, then ICMB is 1, like this. Okay, so these are all actually the protocols which process the packet. Okay, so we have ICMB, TCP, then UDP. Okay, so that means protocol is the one which processes the packet. Okay, so what are the protocols we are using here? ICMP for pinging, TCP, UDP for connection oriented and connectionless protocols. Okay, the numbers also given there. Then basics to IPv4 address. Okay, introduction. Why do we need IP address? You uniquely identify a computer on a network, and to find the destination address for sending the data, we need IP address. Okay. So IP address are uniquely identified in every network. No, there will be so many host machines, computers, mobile phones, or tablets. Okay, we need to identify every device. We cannot put a name. Okay, so what we have is IP address is the unique identification of every computer or every host in the network. And to send a packet to a destination, we need the IP address of that particular destination. Okay, then how do we represent IPv4 address? It is 32-bit long. See, 8888, 4 bytes. 1 byte is, you know, that 8 bits. Okay, so like that, 4 bytes are there. They are represented dot decimal. That's why 192.168.10.1. So decimal numbers in between we have dots. Binary can also represent binary also. Okay. So the first one, so in out of the 8 bits, no, we start with 0 is to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3 to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. Okay, this is the decimal value. Okay, when you add all these numbers, we'll get, see, we have only 128 and one position in the first or the two. Okay, part means it will be 192. If you have all the ones in the bits, means it will be 1 plus 2 plus 4 plus 8, it will be like 255. That's why whenever you are having the subnet mask for class C, no, it's 255 3 times, because the network is three. First three octet is network, means all three is one, means 255. Again 255, 255. Remaining will be host means zero. That's why 255 3 times 10. Okay. Then IP address structure, it has two parts: host part and network part. Host part unique to identify the host, the device. Network part is common to all the devices in the network. Okay. So here 192.168.10.1. How do you identify which one is network part, which one is host part? The subnet mask will identify. So here we know the subnet mask for 192.168.10.1 is /24 or 255 3 times. Okay, so here 255, 255, 255. 255 means all ones. So network means all 1 bits. Host means all zero. Okay, so here this first three is network part and last one is host part. Okay, in that first IP will be 0001. Okay, this one. Okay, 192.168.10.1/24 is the first network, first IP. Then how do IP addressing? Okay, again identifying network part and host part, right? So host part is unique, network part is common. Okay, so here example, community A is the network part. In that, number X street Y John. This is specific for John. This is his address. But we need this network part also. So in this community A, he is living in this house. Okay, this is host part, this is network part. Okay, in this community, many people are living, so everyone will have a different IP. Okay, so it will be different. Gateway is the one which forwards your packet towards next network. Okay, every network has a gateway. That gateway will be connecting your machine to another network. Okay, how do we classify IP address? We have classful IP address. So then we have A, class A, class B, class C, class B, class C. Okay, class A means we have range 000 to 127.255.255.25. These are the IP address assigned for class A. Okay, so here we have host 8 bits, network will be 24 bits. Okay, class B means we have 16-bit host, 16-bit network. Okay, the starting value is 128.00 to 191.255 ending value. Class C we have 24-bit network, 8-bit host. Okay, class D for multicasting. So class C, the range is 192.000 to 223.255 like this. Okay, class D is multicasting. That's for a group of machines communication. Okay, so this is 224.00239.255. Okay, class A used for research purpose. We are not using for user. Okay, so class A 8-bit is the which one host. Okay, and we will have the host part is blue color here. Network is what, white color. Okay, so 8-bit host yani 2 raised to 8. So 2 raised to 8 256. and that usable is 2 raised to 8 minus 2, 254 IP address we can have. Okay, these are networks. Okay, then class B, we can have two octets, 128 bit for network, 128 bit for host. So 2 raised to 128 minus 2 will be number of usable address. Okay, class C, 24 bit network, 8 bit host. So 2 raised to 8. So sorry, here class A, I think class A we have, okay, I already told you class A. Okay, now class C we have how many host bits? 8 bits. Remaining 24 are network. Okay, so 2 raised to 8 minus 2, that much 254 host. Okay, class B 16 bit host, 16 bit network. Okay, class A slash 8. So network will be 8 bits only. Okay, class A network is 8 bit, remaining 24 bit are host. Okay, so what happens in the class A? We will have 2 raised to 24 minus 2 host address, more host address in class A. Sorry, I think I made a mistake. I just, when I was discussing class A, I should have told you network is 8 bit, 24 bits are host. So more address. Class B 16 bit network, 16 bit host. Class C 24 bit network, 8 bit host. Okay, this is host part. So 24 bit host part. Why Mr. 24? 888, 8 bit host. Class B 16 bit network and 16 bit host. Class C only 8 bit host, remain 24 bit network. Okay, like that. Then IP address types. See, we have network address, broadcast address, usable address or available address. Okay. So in a network address, no, there is 192.168.10.00. All the host bits are 0. That will be network address. Broadcast address means, see index example 192.168.10. All 1. It's 255. Okay. So if all the host bits are 1, it will be broadcast address. Okay. In between the network address and broadcast address are available host address or usable host address. So 1, 2, 3, 4 up to 254. Okay. So network address means in class C, we have 24-bit network, 8-bit host address. If all the 8 host bits are 0, that will be 192.168.10.0 is a network address. If all the host bits are 1, it will be the broadcast address 192.168.10.255. In between network and broadcast is usable IP like 10.1, 10.2, 10.3, last 10.25. Okay. So we have 8-bit means we have 2 raised to 8 minus 2 number of usable address. Okay. How do we calculate IP address? Okay, see here. What are the network address, broadcast address, number of available address for class B 172.10, 172.16.10.1/16. Okay. So I'll put this number over here. Write in decimal now 172.16.10 and 1. Network mask /16. That means 2552 2 times. So 255 means 81 here. Here also 81. Okay. So what we need to find out network address. Network address means I told you all the host bits will be 0. So I make these two part 00. So network address will be 172.16.0.0. Broadcast will be all the host bits are 1. So this two parts will be 1. So this one, this one. So what happened? 172.16.255.25 will be broadcast. Number of IP address equal to 2 power how many host bits? Host bits are 16. That's why 2 raised 16 this value. Then how many we can use? Two address will be wasted. We cannot use one for network, one for broadcast. That's why we have available addresses is 2 or usable address is 2 power 16 minus 2. Okay. Range of address is from 172.16.0.1 to 172.16.255.254. Okay. 1 minute. Actually, I wake up before the alarm. Okay. Like that, they given another question. Can solve it. Okay. I will put another video for subnetting. Okay. Later. Then private address means the IP address which is used in the local network, and we cannot use that IP for internet. Example, whatever IP we are using in the classrooms or office, no, They are all called as private address. They cannot be used on the internet. Okay. So example in class A we have 10.000 to 10.255.252. Class B this range. Class C this range. Maybe I have seen in some which one exams they will ask you what is the range of private address in class A. Remember this one. Class B 172.16.00 starting ending at 172.31.255. Class C this 192.168.10.00 ending at 192.168.255. Okay. Public address means the IP address which is assigned by Internet Assigned Number Authority and they can be used in internet. Okay. The use IP address used in internet is called as public IP. IP address used in local network is called as private IP. And there will be NAT. What the NAT will do, they will translate the private address into public address. So whenever you are using a college PC, you are connecting to internet now, your IP address is actually private. That private address cannot reach internet, right? They cannot use it in internet. So what happens? There will be a NAT protocol in router. What they will do, they will translate your private address into public address. Okay. See this one. Your private address will be converted to public by using NAT configured in the router. Mentioned over here. Okay. NAT is a protocol which translate address from private to public. Okay. Special IP address. There are four types of special IP address given here. Okay. Limited broadcast address 255.255.25 means so it is it can be used as destination address. Okay. We can send a packet to this address. Okay. And it's a traffic designed destined for all. It is sent to all the hosts on the network segment to which address belongs. Okay. So whoever or below whichever host belong to that network, they all will get the packet if you give this destination plus 255.2. That is limited broadcast. Okay, we send to all the hosts in that particular network segment. Now 000, it is any address of any network. Address in this block refer to source host on this network. Example: whenever someone want to get the IP address from DHCP server. So whenever someone want to get an IP address from DHCP server, now they don't have IP address. So what they can do, they can make the source address as 000 and they will send the DHCP request. So DHCP server will reply to this address and they will give the IP address for usage. This is 000, any IP address. Okay, see here. This is used as a network address. It means network address of any network. This is example. If a host interface does not obtain IP address during startup, initially I didn't get the IP address during the booting time. The host can send a DHCP request with the destination IP address, limited broadcast address. Okay, so this host don't have IP address, so they want to send the DHCP discover or DHCP request broadcast message. For that, I can use the destination address as 2555. Wherever DHCP server is available in the network, they can send back an IP address. They can communicate with this machine whose IP address is 000. Okay, for that purpose I said 000. So DHCP server will be allocating IP address to that host based on this request. Okay, loopback means 127.0.0.0. I want to make sure, I want to check whether TCP IP is implemented or installed in my computer. I want to do some testing, troubleshooting. For that I can ping 127.0.0.8 because I didn't assign any IP for the computer. Means how do I test TCP IP is working? How do I ping? I can ping to 127.0.0/8 as a loopback IP. Link local IP means whenever your computer is a DHCP client, whenever you are trying to get the IP address from DHCP server and the DHCP server fails to give IP address means you will get a private IP address that is 169.255.0.0. We call it as APIPA, automatic private IP. It's only for temporary purpose. Okay, whenever the DHCP service fails and you are not getting the IP address properly, you can have an IP. You will get an IP address like this called as automatic private IP. Okay, it's mentioned over here. What is DHCP? Dynamically configure the host. Any dynamic host configuration protocol, the protocol which will configure IP address, subnet mask, default gateway, DNS server, everything automatically to the computer's DHCP. Now, why we use IPv6? Because IPv4 is only 32 bits. Okay, it's not enough for the number of hosts are increasing. No, it's not enough to satisfy the computer. That's why we go for IPv6 128 bits. IPv4 has unicast address 1 to 1. Okay, broadcast address to send a group of machines. Multicast to a group. Sending to group, no, we need multicast address. Okay, then IPv6 we have unicast, multicast, and instead of broadcast we have anycast. Okay, Like I told, this one, 0000, any IP, then we have any class. Whoever belongs to that network, they all will get that. Okay. Characteristics, the IPv4 address depletion, and it will be like it keep on expiring. The number of IPv4 address is less in number, so that when the number of hosts increases, now IPv4 address will be deleted. Okay, that will be not enough. But IPv6 now there are so much number of unique IP address because it's I 128. Then what is solution for IPv4? We can use that NAT protocol. Okay. Then the packet header design is also inappropriate. Its packet address is simplified, or easy one. Then we have automatic IPv6 address allocations are there. Okay. Then here we have ARP dependency induced predict. Like we have ARP I discussed in the previous course, this previous chapter. No, we have IP to MAC conversion that will be flooded here. Okay. Subnetting. Why do we need subnetting? See, that's the main reason is to avoid wasting of IP pages. Okay, wastage of IP address. Okay. See, for a class P, we have 2 raised to 16, 65,530 is IP address, but we don't have that much number of host, means that much IP is getting wasted. And here broadcasting also more, because this much host means each host will broadcast, and the broadcast message will be too high, and the network bandwidth will be affected, traffic also affected. Okay, for that what I will do, I'll divide this network into small subnets. Okay, so the number of host address will be limited in the subnets, and different subnet means we need routers in between. So router will stop broadcast. So what happened? The broadcast also reduced, and the traffic also reduced. Okay. Okay, then we'll discuss about VLSM. So we have two types of subnetting. Okay, fixed subnetting, variable length subnetting. Fixed means when I divide the network into different subnets, each subnet will have same number of host machines. Okay, so 172.16.1.0, 2.0, 3.0, everyone will have say 10, or say example say 14 host address. But if you go for VLSM, variable subnet mask, the subnet mask will be different, and here the number of host address will be different for each subnet. Say this will be having say 10 host address, so send 10 host. Okay, this one will have 20 host. This one will have say 30. It depends upon the user requirements. We can divide. That is VLSM, variable and subnet mask. Okay. See, I'm going to explain give an example for how do we subnet. Okay. So here I have a network 192.168.10.0/24. Okay, the default network. Okay, the IP address class. Okay, default class in network. The IP address is the first one. So 24 means first 24 bit is network, last one is host. So first IP will be 192.168.10.1, last one will be 192.168.10.254. So we have 254 IP address. Okay. So this is the network first IP, broadcast IP is 2555. So the last IP will be 192.168.10.254. Now see here we have 254 IP. What I need is, I need to divide this into two networks, and each network needs 126 IP only. Okay. So what I will do, subnetting means take more bits for network from the host. Borrow more network bits from host. Already we have 24-bit network, that's why 24 bits network only, 8-bit host. Now I want to divide this network into two new networks, or two subnets. Okay, so I want to make this into two network means, so the formula is 2 power dash equal to 1. So here I want to, sorry, 2 power dash equal to 2, 2 power n equal to 2. Okay, so how many bits we need to take to get two subnets? Okay, so 2 raised to n equal to 2, that means I want to take only one bit from the network. Okay, from the host part I want to borrow only one bit for the network, so I will borrow one bit. When I borrow one bit, no, this part will become network. Okay, then the decimal value, this part will be 128. Okay, that means the magic number is 128. First network will be 192.168.10.0. Next network will be add 128. That's why the second will be 128. So 192.168.10.128. Understand how do we perform subnetting? How many networks we need? I want two networks means 2 power n equal to 2. So what value of n will give you 2? So 2 power 1 equal to 2. So that means I need to borrow or take one extra bit from host bit. So I will take this bit, okay, and the rightmost bit of host bit, okay, the closer to network part. I'll take this bit, and here we can see I have two values, no, 0 or 1. So first network will be 0, 192.168.10.0 from where we started, and see how many bits are there for network now. 24 plus 1, it's 125. Now what is the next network? We have a magic number. What is the number here? The last one in the network part is the location is the corresponding number is 128. No, that's why the next network will be 128, and we have two networks here. Okay, the new subnet mask is 255.255.255.128. The first network will have IP address 192.168.10.1 up to 192.168.10.126 because 127 broadcast. Second network will be 192.168.10.128, and the first IP is 129. Last will be 254. Okay, see whatever I told, they're explaining. I'll tell you, I'll send you another video for submitting also. Okay, I already have in my Cisco courses. Okay, now VLSM based on host address. Okay, so here also I think another one. How many subnets we need? Three. So three subnet means, okay, three subnet means how many hosts we need. Okay, like that we can calculate. Okay, so this one existing class is segment. The use VLSM to allocate IP address to three subnets. Okay, they're given the requirements, host address, everything. Okay, so first host or first subnet requires. So this is actually VLSM, variable and subnet mask. Okay, so every subnet requires different host. Okay, so first one requires 10 host address, another one requires 8 hosts, another one requires 5 hosts. Okay, so here we'll subnet based on the number of hosts. Okay, so first one needs 10 hosts. That means 2, the formula will be 2 power h. Now we subnet based on host. No? So 2 power h equal to 4. So how many host bits we need to get 10 host address? So 2 power h minus 2. So 2 power 3 is 8. So we need 10. So 2 power 4. 16 minus 2. So we have to take 4 bits per host. That's why 4 for host, 4 for network. Okay. Then another one, if you want to get 8 means 2 power h minus 2. So again, you want to take 2 power 4 like that. Okay. So you can go through that. I'll upload some examples. Okay. It will take some time. So I'll upload the example for subnetting separately. Go through that. Okay. Examples are here. See, when I take 4 host bits means 4 remaining will become network. So the last number, the magic number for last one will be 128, 64, 32, 16. So the networks will differ by 16. First network is 192.168.1.0 for subnet. Second subnet dot 16, third 132. Like that, we go up to 240. Okay, this one. See? And the address will be 192.168.1.0 first one. Second, that's first subnet. Okay, second subnet is dot 16. So first IP will be dot 1. First network, first subnet, first IP 192.168.1.1. Last IP will be 14, 15 is broadcast. Okay, like that. Go through. I given some examples in my CCNA course. Okay, I'll send you the video. Go through that. Okay. ICMP is actually Internet Control Message Protocol, another network protocol. It is used for the troubleshooting the ping and trace route. Okay, so it is used to transmit error and control information between network devices. Okay, this is for collecting network information. Okay, then diagnose and rectify the network faults. Whatever faults in there in the network, how do we diagnose this, identify tasks, how do we solve this? Everything's done in ICMP. Okay, ICMP has a table where we have type of message, what is the code, then description. So 00 echo reply. Whenever you are pinging, no, the reply coming, the ping request will go as echo request, and the ping reply will come as echo reply. 30 network unreachable. 31 host unreachable. The host is not existing or not reachable. Network is not existing or network unreachable means 30. 32 means protocol unreachable. The protocol you are performing, no, the viewing is unreachable, is down. Okay, port unreachable, the port number, source port, destination port, which you are communicating is not reachable. 50 redirect. Sometimes no, we have send the packet to a wrong router. We have to, the router will redirect the packet to the correct gateway router, the destination. Echo request. Whenever you ping from one machine to another machine, actually echo packet is being sent. Echo request packet is sent. Okay, whatever I told is mentioned here. Okay, the ICMP redirection. I have a computer. This computer want to send a packet to server, and the destination IP address in the host is mentioned as 20.0.0.1/24. And see, but this computer has two gateway routers connected with equal cost. Okay, so what happened now? The host will send the packet to router B. Router B, when we open the packet, it can check. It will check that the IP address it is host I want to communicate is 20.0.0.1. It is actually should go through router A. So what the router B will do, it will send a ICMP redirect message. It will tell the computer that you should go back to which router 10.0.0.200 router A so that we can reach the server. This is ICMP redirection. Okay. So whenever the client send a packet towards a destination, it may go to router B in this case. Okay, example router B because both are equal cost. Okay, go to two gateway here. Okay, go to router B. Router B, whenever a router gets a packet, you'll open the content. You can see the destination address is 10.20.0.0.1. That server A that is actually connected to router A. So the machine has to go to router A. So this will redirect, and then I say redirect message tell the machine that you have to go to router A so that reach server A. Okay, that's what I say redirect. Error detection. So you are going to establish check the connectivity from one machine to another machine. Okay. So we are pinging to server machine. So we have echo request for checking the connection, and whenever the machine is replying, they will send echo reply. So for that we use the command ping. So reply come from the machine. That means the connection is established. Okay, how much bytes transferred? This is reply from to whom you are communicating. Their reply is coming. How much bytes? Sequence number. Every packet now we have sequence number. Okay. Then TTL, as I told you, time to leave. When it is zero, the packet will be dropped. Then time. Okay. ICMP error report here also we have trace route command. Okay. When I try to ping to a particular address or a host address, it's not pinging. The request timeout is coming. So the ping we have to troubleshoot where the packet is being dropped, which device has the issue. So for that, what I will do, I'll put a command like trace route. I want to check the reachability of each hop. Okay, so it's a effective method to detect packet loss and delay. Why the packet loss in the middle? Why is this much delay is being taken? Okay, for that we have used trace route. I want to trace the route from route A to this particular device, server address. Okay, so they will tell you how many host, maximum hop 30, packet length 40. Then we can see what are the hops or the in between devices the particular router has gone through. The first one 10.0.0.2, this much time, this much means 17. Okay, then next one they will reach 20.0.0.2. So they trace the route. Okay, this is for troubleshooting. Which whether to check whether any packet drop in the transmission or why the delay is being too much. Okay, then we have IPv4 address configuration basic application. So how do we configure IP address in a router? So we have to go to the router interface into the SysP. Okay, the interface view. There you have to configure. How do we make the interface view? Put the interface number, then interface. So interface command, then ID. Example, remember that interface G0/0. So interface then followed by the type of interface. Giga means G or fast means F, and the number 0/0 or whatever number you have to put here. So we have interface command, then type of interface like Giga or F, fast is then the number. Okay. Then how do we assign IP address? IP address command, then IP address, then either mask or that slash prefix, no, that 24, 25, whatever prefix space. Okay, network prefix. See example in router A, I want to configure IP address 192.168.1.1/24 in giga 001. I'll go to router A I change the user, which one, that router configuration, router name. Then in CISP, we'll go for interface giga 001 IP address given. Either you can give subnet mask or you can give prefix value. If you want to configure a loopback IP means for testing purpose. Okay, you can configure interface loopback 0 IP address 111.255. This one. This is 32. All the exactly same value. Okay, 32 means all the 32 bits are network address. Okay, so exactly same. Loopback. Network address planning. So whenever we are planning to make a network, no, there should be a plan for the network address also. So how much networks, how much IP address needed for each floor or each department. So we should have the plan. Based on that, we can go for subnetting. Okay. See, network segment and RD of RD department has in this network. Okay, so they will be give another this network with slash 24 any 24-bit network and 8 host address 2 raised to 8 254 IP address for this particular network people. Then marketing department is they need this network. So we are giving separate network for each department. Okay, so we need the planning. Then this which class does 201 or 2222564 belongs? Okay, so here the first octet will determine which class. Okay, class A means 0 to 127. Class B, the first octet will be 128 to 191. Class C means 192 to 223. This is belong to class C. A company is assigned C class C. A company is assigned class C network segment 192.168.10.20.0. One of its department has 40 hosts. Which of subnet can be corrected? 40 host means the formula 2 power h minus 2 equal to 40. Which value of host will give you 40 host address? So 2 power 5 is 32. So 32 minus 2, 30. No, 2 power 6 is 64 minus 2, 62. It is greater than 40. So 62. 2 power 6, 6 bits for host means remaining 2 for network. No, that's why 24 plus 2, 26. This is one option. C is also another option. Okay, A and C are options because we need 6 bits per host. Total out of total 8 bits per host, I am taking only 6. Remaining 2 will go for network. That's why 24 plus 2, 26 and 26. This is what coming under chapter 4 network layer protocol. Hope you understood. See you in the next chapter.